Okay, so today we're going to go over how to determine your cut and fill volumes, whether you use the force field surface condition or the height field surface. So we'll start off looking at this one. So this surface was created using a series of different force fields to manipulate that surface. For the most part, you all start off with some kind of flat surface that's shown back here at the very beginning. So there's your flat surface, and this is what it looks like currently. So what we're going to do is determine how much of this is being filled in from a certain datum point and where is it being cut beneath that datum point. So first thing we want to do is determine where that datum point, or in this case, more specifically, a datum surface is. So let's go ahead and project this down to a plane. So it's just right there on the 0, 0, 0 axes. You can start to see how that kind of splits that surface. So we need to figure out that equilibrium or that balance between how much is being cut underneath and essentially placed on top to create these mounds. By doing so, we're going to be taking that surface, that generated surface, and we're going to either be shifting it up to make sure that we have enough fill, or we're going to move it down to make sure we have enough cut. So this is how we're going to determine that, by doing some intersections with components. So what we need to do is project this both in the positive and the negative direction to create some kind of B-rep volume or envelope to intersect with. So we're going to extrude that surface in both directions. So let's just go ahead and make a copy, and one of them is going to go in a positive direction, the one's going to go into a negative. It really doesn't matter what the height is for this. So it's really just kind of a guideline area. So I'm just going to do 60 less than 0. We want it to go in the z direction. So let's go ahead and create our z vector. I'm going to plug this one in first to this one. So here's that positive volume. So I'm going to call this fill volume. Oops. And then this one is going to be our cut volume. And I'll plug this into here, and unfortunately it's going to also in the positive direction, so we have to just give it a small expression to make it go in the negative direction. So I'm just going to do negative x, and that changes. Now you can see that we have this surface extruded in both the positive and that negative direction. So let's go ahead and turn that off. So we're going to be taking our manipulated surface and intersecting it with this volume to determine our fill volume, and then taking it to intersect with this one to determine that cut volume. We're going to use slightly different components for each because each work a little differently. But we also want to make it actually intersect with a surface that is responsive or parametric, so that we can actually shift it up or down in order to balance out those two volumes so that they're equal, because the assignment asks for you to be within 1 cubic yard of cut and fill volume difference. So let's go ahead and move this. We can move this again in the z direction. This can be anywhere between, let's say, negative 3.50 to 3.50. I'm pretty sure we're going to need at least 2 decimals in there to get it pretty accurate. So we'll just start off there. And so let's go ahead and turn this one off. as well as these two real quick. You can see all this is doing is that it's moving it in those two directions. If we turn this off again, that's our datum surface. So we can see if it needs to go shifted above or below in order to, again, determine that cut and fill volume balance. So we can turn this one off, and we'll keep this one highlighted because this is the main one that we're going to be messing around with. So we're going to intersect first this one that we can shift up or down with this extruded volume to determine that fill volume. I'm going to go over to intersect, go to shape, and do solid intersection. So you can kind of see that the idea is that this surface, as it intersects above that with this one, that's going to create that volume in there. So I'm going to drag this into the A, drag this into the B slot, and you will see that when I turn this off, now we have this kind of overlapping surface with our move ones. If I just turn that off, you can see that that is all our predetermined fill volume currently. So let's go ahead and give that a color as well. So I'm going to do custom preview, change that swatch to the deemed fill color, which is somewhere within the blue hue. We can even give it some transparency, accept. So there is our determined fill volume. So that's just, again, a representative of that, a graphic representation. So let's do something similar with our cut volume. Again, these are just showing where those are. We haven't actually determined the volumes yet, but I'm going to go back over to shape, and instead of using solid intersection, I'm going to use solid difference this time. So let's turn this one off real quick. I'll turn these two on. Because it is a little different, you can see that it's technically not going to be the space underneath our B rep. It's actually going to be where it intersects in that kind of underneath. You can almost kind of see how it's almost looks like a standing body of water that's filled up in that landform. So again, I'm going to drag the extruded part into the A input, and then drag this one, the manipulated surface, into our B input. And for the most part, you can kind of just remember that for these intersection components, that your volume component's always going into the A input, and then the surface that you're moving around is going into the B component. So again, you see the very similar outcome, just used a little differently. I can go ahead and copy and paste this one over. I'll turn this one off, turn this one on, and give this more of a red tone. Accept, turn this one off. So then when I have both of these turned on, you can start to see how those are being represented. So the fill one looks just like the landform versus the cut is the invert of that, because you're removing that and then you're placing it onto that. And what's great now is when I use this slider, we can see how well my computer cooperates. You can see where there's what appears a lot of fill versus when we drag it down, there's a lot of cut. The goal for this demonstration is to find out how much do I have to shift that surface in either direction in order to balance those volumes to be pretty close within that 1 cubic yard of one another. So there's our representation. Let's actually determine those values now. So I can go ahead and type volume and use this intersected component where I have multiple B reps. Do that for this one as well as that one. Underneath, we can even drag that one just to be up. So you can see that there's multiple closed B reps for the cut volume. As you can see, there's those two red. Here, if I see 3, that makes sense. There's those 3. What this is doing is finding the volume for each one of those. And what we want to do is actually add all those volumes together. So let's go to math operations, mass addition. I'll drag the volume to this one, drag the volume into this one. Let's use a panel here. We can see that we have 30,115.04 cubic feet of fill volume. Do the same thing down here and see where we're at here. So we can see there's a lot more cut being done, resulting in 36,000 cubic feet. So what we get to do now is figure out that balance between the two. So it's good to have these here as well as finding some kind of difference between the two. So I'm going to do operations, subtraction, drag those into each other, make another panel. Now we can see when we have a negative value, that means we have too much cut. We have a positive value, that means we have too much fill. The idea is that we can just get, again, within that cubic yard. Right now, it's showing in cubic feet. So if we want to get really accurate and get that within, or convert that into cubic yards, let's go ahead and take this value and divide it by 27. So this is going to convert cubic feet to cubic yards. Again, the assignment asked for a difference of 1 cubic yard of cut and fill difference. So we're quite a ways off, but you can see using this slider where we're moving our manipulated surface, we can get pretty close. And it's going to be a pain to kind of drag and shift over, see if that's close. So I'm just going to drag the slider over here to be right within that. And if you don't like that chord kind of going back, you can always go to wherever it's inputted. So this, change that wire display to hidden. So now it's just kind of cleaned up a little. So we can see that there's too much cut being made. So what we want to do is start dragging our slider into that positive direction. So we're shifting it up. You can see that it's starting to get closer. Oops, now we have too much fill volume. So now we're in the positive, so we need to drag that back down. It's going to take a little bit of finessing to get it going, but you'll see the end result. We will be able to get right within that desired volume. So that's too much. Ooh, keeps up going. So let's try negative 0.60 and see where that gives us. So we're still in the negative, so it needs to go up a little bit more. So negative 0.55. Well, we're getting there. So negative 0.5. Oh, we're still getting there. Negative 0.45. Oops. Oh, there we go. So negative 0.45. If I added a couple more decibels, I bet I could get even closer. But right there, you can see that we're right within that 1 cubic yard difference. So there you go. So let's do the same thing. So this is, again, if you're using that method, I'll show that it's really the same exact thing using the other approach if you use the height field to shift it up. So again, I'll just go over this one more time to make sure everyone knows what's going on. So I'll first make the move where we can move this surface in both the positive and negative direction. So I'll do negative, let's try 2.00 greater than 3.00. So So again, all this is doing is shifting that surface in the negative and positive direction. Go ahead and turn that off now. We can take this surface and project it down to our datum point. So again, this is what we're looking at to intersect, and you can already see that there's going to be a lot of cut necessary. We're going to have to really shift the surface down in order to balance those two out. So let's keep that there. We're going to do the same thing. We're going to extrude this in a positive and negative direction. Drag that one down there to negative 60, less than 0. Again, it doesn't really matter how far they go as long as they're beyond that kind of extent. For whatever reason, I start with negative 6. In this case, I'll just change this expression to be negative x to convert that to positive. And there you go. So there's your positive and negative volumes. Again, all we're doing is intersecting this surface with these ones, and we're going to do the same exact thing. So I mean, let's just do it this way so it's not getting too cluttered. So we're going to shift that and intersect it with these two volumes. Let's turn this one off again. I'll again go to intersect. This one again uses the solid intersection for finding that positive value. So A, that extruded one, again, that's our fill volume. This one is our cut volume. That goes into B. We can turn this bad boy off. And the reason it's not working is probably because it's just way too high. So let's drop it down some more. And there you go. Now you can start to see that there's, why is that? Maybe it's too, we have to go in the other direction. Oh, what's going on with this? I guess that needs to go way down. There we go. So probably don't even need to go in the positive direction. So there is our fill volumes. Let's do some preview again. I'm just going to go ahead and copy that swatch from above, drag it into there. So there's, again, our fill volume. Let's use the solid difference for underneath. Drag that into there again. This one always goes in the B value, and so there's our cut volume. I'm going to do the same thing. I'm just going to copy both those, drag it over here and turn that off, turn this back on. So there's those two volumes. So most likely we're going to have to shift it either really far down, not much in the positive direction. So let's see where we're at right now. So again, we need to calculate those volumes, add them all together. So mass addition. You can use a panel to see what that volume actually is. That way I can just copy and paste all three of those for this volume. So you can see it's pretty far off again, so still way too much fill volume. So Let's go ahead and again, find the difference between these two. Divide that value by 27 to convert it from cubic feet to cubic yards. Plug that in, and you can see that our volume is pretty far off again. So again, let's go ahead and grab this number size. So we already know -5 is not enough. So we can, let's change this wire display to be hidden. Drag that back over here. So now I can edit this so that the max value is actually -5.00. Then maybe the minimum is, oops, wrong way. So -5, -6.00. I always do this wrong. So -5, -5. Yeah, let's just do it that way. So, okay, so starting at -6, we can see that it's a little much. Let's go ahead and drag this back up. This one's seems to cooperate a little bit better. Ooh, I just had it. So -5.5. Oops. Let's drag it down a little more. Totally missed what that number was, so I think I saw briefly like 0.23. So, ooh, we're getting close. And -5.63. Too much. -5.61. There we go. So -0.21 cubic yards. That's almost perfect. So again, there's your balance between the two. So one last thing we want to do is, I mean, this is one way you can represent it. There are some more interesting ways where we can also do this, where we can almost do some cross-section cuts of these, which is what you'll see in a lot of other representations of cut and fill volumes, is that it's kind of like the averaging out of section cuts. So let's go ahead and play around with that component of this. So I'm going to just shift this down a little to give us more space. I'll just stick with this one. The technique we're using for this can be directly applied to the other one as well. So what we're going to do is take this surface and we're going to cut it in the x-axis. So we're going to contour it. So let's type contour, drag that into there. The distance and the direction are what else we need to change. So we would need to do it in the x direction. And for this, you can do it maybe 3 to 6, somewhere in those intervals should produce a pretty good output. So we can see there is just simply the curves. So let's actually convert that into surface by going to the boundary surfaces. You can go ahead and flatten that. It really doesn't matter, but so there's those. Let's maybe just do 4. And I'm just going to now drag those up here and fill them. So there's that volume being represented. What's nice, I can just take this. I guess I don't need to copy the color. Let's take this. Again, we're going to use this volume. Drag it into here. This now goes over here. So there you go. Now there's the red. I mean, you don't have to use these colors. You can get a little more creative. I always kind of like these color tones for whatever reason. Give it a little more transparency. That starts to look pretty cool. So the thing to know now is that you might have this great representation of this, but you aren't going to be able to directly bring this into Illustrator to edit without using a couple other plugins. I'd rather you guys just focus on getting to this part and having a high quality representation. So something that you can do, which is nice, is that you can actually capture this view at a pretty high quality and bring that into either Photoshop or Illustrator to match with everything else. So let me go ahead and turn this off. And I'm going to use the command capture or view capture to file. So view capture to file. It's going to ask for where this is. So you can see those are some of those examples already. So let's do this one first. Yes. So that's going to just go ahead and create that file. So let's go to wherever that is. So here's the one I just produced. Most likely your computer is going to be set to a really low resolution. So in order to actually produce a higher resolution, I'm going to do a hyphen first and then do view capture to file, choose browse to choose this one. So I'll do save it here. Yes. So you can see that the scale are pretty low. So I'm going to make these about, let's try 2000 by 2000, do a scale of 3, hit enter. Let's go back over here. So here's that one that I just made. When you zoom in, you can see it's pretty high quality versus that other file. So here's that first one where we didn't change those settings. And you can see it's pretty low quality. So that's going to give you a good high resolution output from this. So yep, that's it for today. Good luck.